students. Today we'll be talking about thermal energy, and under the thermal energy we'll be talking about the heat transfer. Before we further, what is heat? We can define heat as a condition or quality of being hot. A condition or quality of being hot. Also, what is energy? You can define energy as the capacity to do work. I believe all of us know that energy is the capacity or ability to do work. Now let's go to the meaning of heat transfer. Let's talk about thermal energy first, or heat energy. Thermal energy, we can call it heat energy, we can also call it thermal energy. It's the same thing. So thermal energy or heat energy is a form of energy. We all know that. It is a form of energy that flows from a hot area to a cold one. A form of energy that flows from a hot area to a cold one. Heat flows is the flow of heat in an object like iron rod from the area of high temperature to the area of low temperature. For example, if you put your stew or your soup on the stove or a gas burner and you forget to remove your spoon out of it, if you leave it for some minutes, you will discover that the spoon inside this stew is already hot. So this is a form of heat transfer. That means the heat transfer from where it is being hot, that is the base of the pot, to the handle of that spoon. So that is heat flow in heat energy. Hot body loses heat to a cooler one. Like I just said, the hot body, place that is very hot, loses heat to a place where it is more cooler. Heat can be transferred by three processes. We can transfer heat by three processes, which is conduction, convection, and radiation. We'll be looking about the processes of heat transfer. We can transfer the three methods of transfer of heat or heat transfer. We have it as conduction, convection, and radiation. Now, this diagram illustrates the three methods of heat transfer. The first diagram, you can see the source of heat under and how heat is being flow from the hottest region to the less hot region. As you can see in that first diagram. The second diagram, you can see the heat conduction through convection. This one takes place majorly in liquid and gases. It moves from where the heat is being hot the most and to where it is being cooler. And that's what happens when you put your water on your gas or your buzzing burner. We discover that it is the base of the kettle that will first get it up. Before you know it, it circulates around inside all the kettle. And the other one is radiation. This one doesn't need medium, but it needs a vacuum for the heat to transfer. And that's why when you put a lantern inside your room and you close the door, before you know it, you notice that the room is getting hot or heat up. Also, if you light a coal pot and you put it inside the room, the one that you use in agriculture when you are brooding to keep your chicks warm, this is a form of heat radiation. Now let's talk about conduction. It is the process by which heat energy is transferred from one region of high temperature of a body to a lower temperature body along a stationary solid material. That means that material is stationary. You are not moving that material from one place to another. Like the one I explained, when you put your stew or your what is it called, your soup on the stove or on a gas, before you know it, and you forget your spoon inside, before you know it, the heat transfer from the pot to your spoon after some time. So it makes use of a solid material, a stationary solid material. It is processes that make a pot on fire to transfer heat to the handle of a pot. You can see what I'm trying to say. It's this process that makes a pot on fire to transfer heat to the handle of a pot. Even if only the tip is in the fireplace, this method of heat transfer requires a solid material. That means before this can happen, before conduction can happen, there must be a solid material that is being used. Now, here you can see the illustration. The first box painted red is block A, while the second one is block B. They are apart. There is no heat transfer because they are not in contact. Now, assuming this red box is very hot, the box A is very hot and box B is cool. If they come in contact together, you can see that there is heat flow from box A, which is very hot, which is a higher temperature, to the what? To the box B, which is of what? Lower temperature. That this heat move and circulate until both body becomes the same temperature. You can see the two blocks are the same temperature and the heat flow stops because there is no more heat that can flow from A region to the what? To the B region, because all of them now have equilibrium or the same heat or the same temperature. That is conduction. Now let's talk about convection. Let's talk about convection. Convection. This is the transfer of heat through the exchange of hot and cold molecules. This is the process through which water in kettle becomes uniformly hot, even though only the bottom of the kettle contacts the flame. I think I've explained this earlier through this diagram. The diagram we have here, the way heat is being transferred from the base of the kettle to all the other parts of the kettle. And that's why when you put water inside your kettle and you put it on the buzzing flame, it's only the bottom of the kettle that comes in contact with the heat. But before you know it, the rest of the water gets warm up. So this process is called what? Convection, and it only takes place in liquid and what? And gas. The material medium for this process is liquid and gas only. That means it doesn't take place, convection doesn't take place in solid materials, but it takes place in liquid material. This is a way small amount of hot water can warm a full bucket of water, of cold water. So that is convection. This is the illustration here. You can see the illustration, how this arrow is signify the movement of each flow. You can see the red arrow coming down, eating up the rest of the water, and that's how it circulates. Sorry, that's how it circulates through convection. Now, the last one under the three major ways in which heat is being transferred is radiation. Radiation. This one doesn't really need a medium, but it needs a vacuum to move. Let's say this is the transfer of heat via electromagnetic or you can call it infrared radiation. This is the principal mechanism through which a fireplace warms a room. An example of this is our, what is it called? Yeah, sorry for that break. An example of this is our oven. Oven. You can use a very good example is an oven. The radiation inside the oven makes the object or anything that you put inside the oven, it makes it hot. This we can call this radiation. This process does not require any material medium, but the heat is transferred through a vacuum. A vacuum. A vacuum means a empty space. This is what enables the heat of the sun to reach us, or fire burning far away while we feel the heat somewhere. If you are burning a bush beside a road and you pass beside that bush, you notice that you feel the heat, whereas there is nothing that is contacting you and the fire together, just an empty space. That's what we mean by a vacuum. So when you pass through a road and the fire is burning beside that road, you feel that heat as if that thing is burning you. This process is called what? Radiation. The sunlight, the sun rays, the heat we feel when there is a high sun intensity in the afternoon. This is also through a process of what? Radiation. So those are the three ways in which it can flow. Now let's see this experiment. You can do this by yourself at home. Just try and hold a thick piece of copper, put it inside the buzzing burner, and just give it like 5 minutes and see if you can still continue to hold that buzzing, the piece of metal. You notice that the piece of metal gets hot to an extent that you won't be able to hold this piece of metal again. This process is called what? Is what is called conduction, because that is the transfer of heat from where it is higher to where it is lower. So hold a thick piece of copper wire in a buzzing flame. Can you continue to hold it for a long? No. The end of the wire in the flame becomes hot after a short time. As does the heat get along the wire. The only way in which this can happen is for the heat to be passed on from one particle to the next until it reaches the far end of the wire. Sorry for that. Then we say that heat is conducted, and the process is called conduction. Only metals can conduct heat. Yes, it's only metals that can conduct it. Non-metals cannot conduct it. Give me an example of non-metals. Example of non-metals are wood. They are notebook. They are your phone that doesn't have a metal at the back. Your small phone. You can see your table, your chair. All these are example of what? Of non-metals. But good example of metals are what? Are iron. Iron conducts heat very well. However, we have good conductors and bad conductors. Before we now move to this good, what are conductors? Let us explain what are conductors. Conductor is something or material that can transmit electricity, heat, light, or sound. Anything that can transmit it, that can transmit light, that can transmit sound, we call it what? Conductor. So let's see the examples of good conductors and the example of bad conductors. Now, good and bad conductors. Good conductors are substances which conduct heat readily. That means a substance that is readily conducting heat is what we call what? Good conductors. Why? All metals you can mention of iron, cobalt, any metals conduct, they are all good conductors of what? Of heat. Then we have bad or poor conductor. There are substances which do not conduct heat readily. That means they don't conduct heat readily. Example is liquid. Gases are also bad conductors. We have plastic, water, etc. are example of bad conductors. So this brings us to the end of today's lesson. Let's check. At the end of this lesson, I believe you must be able to explain how heat flow. You must be able to explain, to mention and explain three ways of which a heat can be conducted. Then we should be able to explain how we can carry out an experiment to illustrate heat conduction, and we should be able to state three ways of applying conduction in our homes. So these are the assignment and is expected to submit latest by Saturday this week. You explain how heat flow, you mention and explain three ways of conducting heat. You explain how you will carry out an experiment to illustrate conduction. You should also state three ways of applying conduction in our homes. So this brings us to the end of this lesson. I will be available anytime. You can just try and contact me through my WhatsApp page if you have any question pertaining this topic. Thank you and have a very nice day.